everyone, and welcome to Unit 5, Part 1. Today we are going to talk about Lesson 30.1, which starts on page 433 in our Springboard textbooks. You will need a pencil and a calculator. Now, as you will see from our learning targets today, we are talking all about area of rectangles and parallelograms. Now, this figure that they are giving us to start is a tabletop, and it says to make this tabletop on top of maybe an island or something, think HGTV, it costs $8.50 per square foot. Now, this shape here, this L shape, is not necessarily a rectangle or a parallelogram, but one thing we can do is divide this up into two separate rectangles so that we do have rectangles that we can find the area of. Now the area, you may or may not remember from your other math days, is the area of a rectangle is base times height. So what we can do is we can divide this up. You can either divide it that way, or maybe you would want to divide it this way and write out the two different rectangle lengths. So notice if we divide it this way, we already kind of have the length and the height of this smaller rectangle and the length and the height of this other rectangle. So individually, 2 times 3 is 6 feet, 6 times 2 is 12 feet. So together we have a total of 18 square feet, right? Anytime you have area, it's units squared, okay? So in order to figure out how much money this is, if it's $8.50 per square foot, we're going to have to multiply this, and we see that we end up paying $153 for the tabletops, okay? Now, what would we have to do if we wanted to make a parallelogram shape? Well, what we can see here is if we have a rectangle, right? We know that the area is the base times the height, right? Now, if we take this rectangle and we cut off a piece of it and slide it over, notice now our shape is in the shape of a parallelogram, right? It's got a little slight kind of slant to it. It's a parallelogram. The area we are taking up, though, is the exact same as what it was before. So whether it was, we didn't add any extra area to what we were taking up. So what's actually going to be true here is that the area of our parallelogram is also going to be base times height. Okay, now you have to be careful though, because the height of the parallelogram is not the side length. We're talking still the height where it's perpendicular. So your height of your parallelogram is always going to be where you're creating a perpendicular, and then your base would still be that length there. So you have to be careful with your parallelograms. You don't necessarily need the side length, you need the height from base to base. And height is considered distance from base to base. So keep that in mind as you're writing these down. Now, when calculating then, and we actually look at this parallelogram, again, they're kind of giving you a piece of information here that you do not need. You have the bases are going to be 3, and you have the heights are going to be 1.5. So this 2 is kind of useless to us right now if we're looking for the area, because we want the base times the height, aka 3 times 1.5, for a total of 4.5 square feet. Now again, if we're trying to figure out how much money it would take to make this tabletop, we would have to take 4.5 times the amount of money that we said it costs, $8.50. So 4.5 times $8.50, we would cost $38.25. Now, sometimes we are going to have a picture on the coordinate graph. So we're going to need to count the distance to figure out our base and our height. So we had to move from -3 to 4 for a total of 7 units. And then our heights, we have 2 going up to 5 for a total of 3 units. So our total area here is 21 units squared. Now, another thing that you may be asked for is the perimeter, right? And the perimeter of a figure is found by adding up all 4 sides. So all 4 sides here, the perimeter would be 3 plus 7 plus 3 plus 7 for a total of 20 units. Now notice perimeter is units, area is your units squared, okay? Let's see. Now, as they are asking us for a parallelogram, if we sketch this picture, we're at -3, 4. We are at 2, 2. We are at 2, -4. And we are at -3, -2. And we see we have a parallelogram. Now, we don't actually need the distance formula to find the height. Okay? If we're looking for the area, the height, again, is where this is perpendicular. So we can just count, since this is vertical and horizontal, the lengths here. So to go from our value of 4 down to -2, this is a total of 6 units, and the height from from -3 to +2, this is 5 units. So the overall area is just going to be 6 times 5, or 30 units squared. Now, if we wanted the perimeter, we know that we have the sides of 6 and 6. The problem is we would need these side lengths on that, and that's where our distance formula would come into play, because we could plug in, for instance, the point -3, 4, and 2, 2, and figure out this distance here to help us with the perimeter. Now, for time's sake, I'm going to skip that, but we could do that. Now, the next piece of this then is using a composite figure and in order to find the area. So we kind of already talked about this with the first example in the notes. This was a composite figure because it was composited of 2 different rectangles. This time we have a composite figure of a rectangle and a parallelogram. Now the area of this rectangle is going to be found by doing our base times our height. So we have 5 times 6, our base times height, for 30 units squared. The area of this parallelogram over here, however, is dependent. We have the base, but we don't have the height, right? Now, something we do have is the length of this side is 5. And notice we have a right triangle occurring here right now with a base of 3, a hypotenuse of 5, and we can find this missing height using Pythagorean theorem, so that we are finally able to actually calculate the area of the parallelogram. So remember Pythagorean theorem, our c this time, our hypotenuse is 5, is going to equal 3 squared plus the height squared. 25 minus 9 is going to give us our h squared. So h squared is 16, which means our height here, when we square root, is 4. So the area of the parallelogram is the base of 3 times the height of 4, so 12 units squared. Now finally, you're going to want to find the total area. And the total area then is going to be found by adding each piece together. So the total area, we're going to take the 30, we are going to add that to the 12 for a total of 42 square units. Oops, and actually in this case, they told us the units were feet. Okay, so feet squared. All right, so some final examples here. I'm going to give you a moment to try number 7 on your own. On this one, you could have divided it up a couple different ways. If you divided it this way, though, what you're going to notice is this piece is 4.5, which means this piece over here is 4.5, and this height here is going to have to be 3. So in the bottom rectangle, we have side lengths of 3 and 9 for a total of 27 square units, millimeters squared. And then up here, we end up with actually a square, 4.5 times 4.5, all the way around here. 4.5 times 4.5 is 20.25. And again, to get the total area, then you would have to add them together for a total of 47.25 square millimeters. Now the next one wants us to determine the area and the perimeter of a rectangle whose length is 12 and diagonal is 13. Well, remember in a rectangle we have a lot of right angles, so similar to what we did up above, we're going to need to solve for the height using Pythagorean theorem. Now what you should get when you solve this is that we end up with 169 minus 144 for a total of 25. So H is 5. Now, because of that fact, now we have the base and the height. Our area is going to be 5 times 12, so 60. In this case, centimeters squared. And then the perimeter would come from adding up all 4 sides. 12 plus 12 plus 5 plus 5 is a total of 34 just centimeters, and not centimeters squared for perimeter. Last but not least, we have 2 final examples with some parallelograms. Okay. Now notice on both of these we are missing our height, and we don't know enough information here to be able to use Pythagorean theorem to find this height. What we do notice though is that this little triangle here is a 30, 60, 90 right triangle. And we are given the side across from the 90-degree angle. So remember in 30, 60, 90s, our hypotenuse is double the length of our short side. So this little piece here would be half of 4, which is just 2. So the height across from the 60 is divided by 2, the 4, and multiplied by the square root of 3. So now we can calculate the area because we have the base, but we now also have the height is 2 square root 3. So our area, 5.5 times 2 square root 3. We have a total of 19.1 square feet. Now, we also can find the perimeter on that one because it did ask for both area and perimeter. Perimeter, we would end up adding 5 plus 5, 5.5 plus 5.5 plus 4 plus 4, and that's going to end up being a total of 19. Last but not least, on part B. Okay, on this one, notice we have a 45, 45, 90 right triangle. And our length sides here are both going to be 7. So in order to get the height here, remember this is equal to x times the square root of 2. AKA, to get one of our legs, we need to take 7 and divide it by the square root of 2. Okay, so the area on this one has a base of 14 and then a height of 7 divided by the square root of 2. Now, you could officially rationalize that and all that, but we're going to just approximate 7 divided by the square root of 2 in the calculator, so don't worry about necessarily simplifying that. So we're going to just do 14 times 7 divided by the square root of 2. And our final approximation is about 69.3 yards squared. And the perimeter then is going to be 7 plus 14 plus 7 plus 14 for a total perimeter this time of 42 yards. Okay. Thanks everyone for watching, and we'll work more with the area of rectangles and parallelograms in class.